Hey Kim, how are you? You ready? You nervous? A little bit? Alright. Clara?
Fears could be heard. So before I start, I want to ask you guys, what are you afraid of? Like, shout things out.
Mr. D.
Children.
Okay. And do you know where these fears come from?
Bio class?
So sometimes people might say like, oh, I was bitten by a dog when I was younger, so now I'm afraid of dogs. But a lot of times we don't know where these fears come from. And there's a social stigma against being afraid that's like, oh, you're a wuss. But maybe we don't have control over this. So for the experiment, the researchers used a strain of mice called M71 lac-Z. And there's a reason they used this specific strain, which I'll get to later in the experiment. The variable was called a fear-potentiated startle test. So they exposed the mice to a scent. In this case, it was either acetophenone or propanol, and they zapped the mice. And by doing this, the mice began to associate the shock and the fear that comes with being shot with the scent that they were exposed to. After this, the researchers computed an OPS score. This stands for odor-potentiated startle. And this was a measure of the mouse's sensitivity to the scent. Does that make sense? Yeah.
So they sensitized them to both, they potentiated them against both the acetophenone and the propanol?
So there were 3 groups. The first one was F0 home, so these were the control mice. There was a group that was conditioned just to acetophenone, and then one conditioned just to propanol. And then they mated these mice with naive females, so females who hadn't been conditioned to anything. And they had 3 groups of offspring, F1 home, F1 ace, and F1 pro. And none of the offspring were conditioned, it was only their parents. Okay. And then they exposed these offspring to the 2 odors, either acetophenone or propanol, and they computed their OPS scores. And so having a higher OPS score just means that the mouse is more sensitive to the scent. Okay. So, before we look at the graphs, just like a reminder, none of these mice had been exposed to the odors themselves. It was only their parents that were. And so this graph shows the OPS scores when the 3 groups of mice were exposed to acetophenone. And you can see on the left is the F1 home mice, so the offspring of the control mice, and theirs is mostly around 0. And the same with the F1 probe mice, theirs is around 0. And then the F1 ace mice, so the offspring of the mice conditioned to acetophenone, their OPS scores are a lot higher, which means that somehow they've become more sensitive to acetophenone. Okay. And then this is the same experiment, except this time the mice are exposed to propanol. And so you can see the F1 home and the F1 ace groups are around 0, and the F1 pro, their scores are higher. Yeah.
Does the OPS score indicate a preference for, rather a tendency to move away from the odor of a particular substance, correct?
Yeah, well, it measured their sensitivity. So yeah.
So does a negative score indicate a preference for that substance? Or is it, what does the negative score signify, I guess?
Negative score, yeah, or...
I mean, none of them have a significant preference for the substance, but, or a significantly negative score, but...
Yeah, well, yeah, I think the negative score is like a preference, and then so if they have a higher score, so say like this one, that means that they were more like averse to, or more they picked it up. Okay. So then the next thing the researchers did was they looked at the neuroanatomy, so what was going on the cellular level in the brain. And so, well, mice and humans have things called olfactory sensory neurons, and these are cells in your brain that detect odor. They're specific to each odor, so you have different odor settings for picking up like apples versus peaches. And then the axons of the ossins form the glomerulus. So, okay. So if we look just on the blue and black part, so these, the squares and the triangles are the odors. So in this case, acetophenone or propanol. And then this entire thing is the olfactory sensory neuron. And this part on the end is the axon, and so these form the glomerulus. Does that make sense?
Mm-mm. One more time, please.
Okay, so these are the odors, so acetophenone or propanol. And then this is the olfactory sensory neuron, so it picks up the scent.
So that's in the nose.
Yes.
It has to be, right? Because the odor is coming in contact with it. So, okay.
And then these form glomeruli. These are just the ends of the scent. Okay. And so the reason that they used the strain M71 laxity is because they have things called M71 OSNs, which are designed specifically to detect acetophenone. So for this experiment, the researchers first measured the number of M71 OSNs in the offspring mice. And so having more M71 OSNs, that would imply that you had been exposed more to acetophenone. So say you have 2 mice, and then you expose one of them to acetophenone, their body will naturally produce more M71 OSNs to be able to pick up the scent. Does that make sense? So like having more would imply that you have been exposed more to the scent. So this is the graph that shows the number of OSNs. This is the offspring of the control group, and this is the offspring of the propanol group. And you can see both of them had around 250 OSNs. And then you can see with the F1 ACE mice, they had closer to 300 per mouse. So again, this implies that they've been exposed more to acetophenone, but they hadn't, because as I mentioned before, none of the offspring mice were exposed to any of the scents beforehand. Yeah.
The F1 ACE-M71s were the children of the ACE mice that were frightened, right?
Yeah. They were the offspring of the mice that were conditioned to be afraid of acetophenone.
Right. Okay.
Yeah, Liz.
Is there a statistically significant difference in the levels of the OSNs of the acetophenone F1s and the other? Like, it doesn't look like there's that much of a difference. Like 200.
Yeah. Well, okay, so it's like, well, this was only one part of the brain. So I guess, yeah, so they're only looking at one part of the brain. So if you took all the different parts of the brain, it would be significant. So, yeah, so none of these mice had previously been exposed to the odors. So somehow these, the F1 ACE mice, have inherited having more OSNs. Okay, so then the next thing the researchers did was they wanted to stain the mice brains and see like a visual. So the way they did this was using something called beta-galactosidase. So the M71 OSNs, they produce this enzyme called beta-gal. And what enzymes do is they break compounds apart. So here, beta-gal breaks apart the compound X-gal, and this produces a blue precipitate. So this is X-gal. When you put in beta-galactosidase, it'll break it apart into this, which is colorless, and then this, which forms a blue precipitate. So then by doing this, by putting X-gal into the mouse's brains, they could visually see how large it was, basically. Yeah.
So the OSNs will look blue? Is what you're saying?
Yeah. Well, actually, okay, so where this specifically goes to the axon of the glomerulus. So, yeah, this is what they're staining, and this will look blue.
Why would only those glomeruli have X-gal?
Which glomerulus? Like the M71.
Mm-hmm.
Okay, they don't have X. They have beta-galactosidase, and then because these cells just happen to produce them, that's why they picked this strain of mice.
Okay.
And then the researchers put in X-gal.
Oh, do you know how they put in the X-gal? Did they inject it or?
So,
Okay.
yeah. So basically, all you need to know is that they stained the mice brains blue. Okay.
Oh, I get it. So only the those populations produce the beta-galactosidase. So it didn't matter how you give the beta-galactosidase. Only those would stain blue.
Yeah.
Okay.
Okay, so then, so they stain the glomeruli, and if it came up more blue, this would mean that the glomerulus was larger, which would mean that the glomerulus had been activated more, which would imply that they had been exposed more to acetophenone. So these are the results. This is the F1 home, and this is the F1 pro. And you can see that these are both significantly less blue than the glomerulus of the F1 base mouse. So this means that, well, okay, so going back here, this would imply that the F1 ACE group has been exposed more than the other two groups to acetophenone if they had them. So this indicates that somehow they've inherited having the larger glomerulus. Does that make sense? Okay. So then finally the researchers wanted to know what was going on at the genetic level, so in the gene itself. So the gene that expresses the M71 OSN is called ULFR151. And the researchers looked at the amount of methylation on the gene, because if the gene is methylated, then the M71 OSNs won't be transcribed and the mouse would have less of them. Okay. So yeah, so the more methylation there is, the less transcription of M71 OSNs. Okay. So then this is for the original group of mice, so the mice that were exposed to the sense and conditioned. And you can see the on the left is the F0 propanol group, and theirs was around almost 100% methylated. And then for the F0 ACE group, theirs was closer to 80 or 90% methylated. So this means that for the F0 ACE group, they had less methylation and so more transcription of M71 OSNs. And this makes sense because these were the mice that were conditioned to the sense, so their body has responded to the conditioning. And then, so next the researchers looked at the same thing, except for in their offspring. You can see that this is very similar. The F1 probe had close to 100% methylation, while the F1 ACE had much lower, well, significantly lower amount of methylation. And so this means that somehow they've inherited this. And yeah, okay, so just an overview. What we just looked at, we saw that the F1 ACE mice had less methylation on their gene, which meant that they had more M71 neurons. And we saw this in the glomerulus visually, and then also in the numbers. And then, so because they had more M71 OSNs, this made them more sensitive to acetophenone. And the acetophenone was originally linked with fear. So somehow these mice have become, have inherited this fear of acetophenone. So, in conclusion, researchers found that sensitivity to odor can be inherited. And then, but since the odor was linked with shock or fear, this means that fear could be epigenetic and hereditary. And so, finally, back to my original point, it's okay to be afraid because you don't always have control over it. All of these opportunities in science, the Journal Club team for preparing me really well. Project 80, because there's a really cool commercial about this coming out soon. And then all of you guys for coming. Yeah.
Does this mean theoretically that my students' children might be afraid of me too?
I guess. Or maybe like our children would be afraid of you.
Nice shirt.
Thanks, Mr. D. Nice shirt.
Anyone have any questions?
Come on, guys. Some of you have to have questions about this. This is a pretty easy one to understand. The concept.
So she did a good job and they get it.
Right. But the point is that you figure out more about it. I'm going to kill you.
The camera picked that up.
Yeah. Catherine.
Okay, I was just wondering, so if our odor is also like hereditary, then I guess like would our fear that would also be kind of like inherited also be like triggered by odor as well, or would it just be kind of like it would just kind of happen?
Okay, well, so yeah, this experiment was definitely just for fears that were linked to odor. So, as far as I know, I don't know about like something that maybe isn't linked to odor. So, but definitely, yeah. Yeah.
Alright, so the F1 mice, one that inherited the 71, they're not actually afraid of it, they're just more sensitive to it. Because they haven't been administered or the shock. So they don't actually have the fear thing.
Yeah, well, I mean, because there isn't really a good way to actually like measure like fear, but so the sensitivity. So just the fact that they were more sensitive to it is kind of like, oh, they're probably more afraid. But yeah.
Did that answer your question?
Yeah.
Are you sure?
Yeah.
Did the original generation and the F1 generation have any contact with each other prior to?
So are you talking about like nurture versus nature? Okay.
I know it's not quite as visible in mice, but
So they actually, I left out a couple of the experiments that they did, but one of them was where they did cross fostering. So they had like mice with the offspring of the ace and then the offspring of the probe, and they had them raised by like the opposite parent, and they found that the results were the same. So basically that nurture had nothing, didn't really have an effect on. Does that make sense?
yeah.
Yeah.
You said that they didn't have a good method to measure actual levels of shock, but in that case, how did they actually link the sensitivity to the odor to a shock response?
Oh, no, they didn't have a good way to measure like fear. Well, because you can't really be like, oh, on a scale of 1 to 10, I'm 10 afraid. But like, so they connected the sensitivity to fear in that if you're more sensitive to something, like you're more like the fact that you pick it up more easily means like you're more afraid. Is that?
They did the same test with the parents as they did with the children, and they found the sensitivity test, which they translated into fear, and they found that both the parents and the children had elevated levels of what a normal mouse would have when exposed to this scent.
But how did they actually make the jump from sensitivity to fear?
Because it shocked the parent mice, so that when they smelled it, they were shocked, and that they associated the smell with being shocked, so they got the response, the fear response, didn't want to smell the smell because they knew if they smelled it, there would be a shock.
I
So it's
understand.
like the parents feared that, and then it's how does that connect?
They have to assume that sensitivity reaction is fear. They don't have a way of asking the mouse, are you afraid?
So are you suggesting that it might be something else?
Well,
Like a
yeah,
strong-
I'm just wondering. I'm wondering if it actually is a safe assumption to say that a mouse that will smell something more strongly will be afraid of that thing, because like, even if you can smell, say, apples really well, you're not going to be terrified.
But you're not getting shot.
But yeah, when
That's
you
why they
Well,
did
how do they gauge the shock? How do they even know that the mice are shocked?
They shocked
did.
the
shocking
And then how does the mice?
Like they gave a shock to the
I think you
mice.
mean how does they know
Oh,
that
wow.
the mice are afraid?
They actually electrify their mind. Okay, I thought that you were talking about emotional response.
No.
Not actual electric shock.
Yeah, like.
Kim, is it possible the fear was passed on while the child was in the womb? Did they do any transplant experiments?
Yeah, they did IVF.
They did an IVF, okay.
Like it didn't affect
the children were still afraid.
Yeah, that's kind of like what's happened with that. So this one it was limited just to fear that was associated with them. So yeah, so like maybe if you're afraid of dogs, your children won't necessarily be so at this point they're really not sure, but definitely for sense there's a possibility that it's inherited. I guess maybe that's
So guys, next week is Bridget, and she's going to be talking about if poverty impedes cognitive function. So that's just like not to be obnoxious, but like, are people who live in poorer conditions stupider, or are they less educated because they have to worry about something else, like when their next meal is? Ignore him. And yeah, come out next week. Yeah.
What are you doing, Mark?
That's why you record that way.